What's up? What's up? It's your man, Jimmy Chan. So let's talk about Z-score. Z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. We find it by subtracting the mean from the data value and dividing this result by the standard deviation. Okay, now this happens on both the population and the sample at Z-score, that is. So in the population Z-score, we just got to make sure that we're using the population mean and the population standard deviation. And in the sample, we got to make sure that we're using the sample mean and the sample standard deviation. So let's take, for example, that this season, Red Sox had 876 runs, Dodgers had 804 runs. And let's see who had a better season compared to their league. Red Sox are in the American League and the Dodgers are in the National League. So let's compare them based on their leagues. So if I was to find, let me see here, the Z-score for the Red Sox, let's see here, that is going to be their number of runs that they had minus the mean, which is 731.2, divided by the standard deviation, which is 72.6. And if I was to find the Z-score for the Dodgers, that's going to equal to number of runs that they had minus their mean for the National League, which is 710.8, divided by 60.2. And I feel like I should do the Red Sox in red for some reason. So the Z-score for the Red Sox came out to be 1.99, and the Z-score for the Dodgers came out to be 1.55. So the way I want to look at this is on this right here, right? So 1.99. So again, the Z-score is the distance away from the mean, right? Either positively or negatively away from the mean. So obviously the higher it is, the better they did. The lower it is, the worse they did. Okay, so we look at this, the Red Sox is over here at 1.99, which is not that right there. So let's go and bring that in just a little bit. It's very close to 2 right there. So this is the Red Sox. Right? And the Dodgers are right here at 1.55. So not quite center, it's just right of center. That's a little bit too right of center. And there's a crooked right of center. Okay, so let's say that, and that is the Dodgers. Okay, so since the Red Sox is further to the right, that means Red Sox had a better year in scoring runs. Okay, so that is the case right there. All right, so let's go ahead and move on and talk about percentiles. Percentile, the kth percentile denotes that P of k, or P sub k, okay, the percentile of kth amount of a set of data is the value such that the k% of the observations are less than or equal to the value. Okay, so let's take, for example, Jennifer just received the result for her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does that mean? Well, it could mean several things. First, Jennifer scored better than 74% of the population. Okay, we can say that. We can also say the score 600 I shouldn't say it that way. I should say it this way. 74% of the population scored .600 or less. And what does that mean? That means that 26%, right? 100 minus 74 is equal to 26, right? So I can say that 26% of the population scored better than Jennifer. Okay? So we have to understand that if we look at this curve here, right? If I have 74% this way, that means we must have 26% in this direction because the total of these two should be 100%. All right? So let me go ahead and, because this has nothing to do with that problem. All right. So let's talk about quartiles. Quartiles, as you guys can see, you can see the word quarter in it. So the first quartile is the bottom 25%, the data from the top 75%. Okay, so the first quartile is equivalent to the 25th percentile. So the bottom 25% of the data. The second quartile is the bottom 50%, hence is the second quartile or the 50th percentile, which is also equivalent to the median. And the third quartile is the bottom 75%, or also known as the top 25% of the data. So the third quartile is equivalent to the 75th percentile. All right. So in order for us to do this, what we want to do is we want to cut it in half first. So let's go ahead and jump into an example. So one of the examples we did back in the day was where we had 10 scores, right, in the class. And the scores were 82, 77, 90, 71, 62, 68, 74, 84, 94, and 88. Let me make sure. 2, 4, 6, 8, 10. So there's 10 of them. So the first thing we have to do is to put them in order, right? From least to greatest. So put data in ascending order. Least to greatest. All right. So what do I have here? I now have, let me see here, 62, then 68, then 71, then 74, then 77, then 82, then 84, then 88, then 90, then 94, and let's make sure 2, 4, 6, 8, 10. So I'm still good. I still have 10 pieces of data. All right. So the next thing we want to do is find the median. Right? So in other words, I want to cut this data in half. Right? So when I cut this data in half, I have this. So here's the median. Oops, let me do it this way. Actually, let's do this direction. Okay, so I cut the data in half. If you notice, I have 5 pieces of data here and 5 pieces of data here. So I'm between these two. So to find the median, or the second quartile, which is also known as the 50th percentile, right? What we have to do is take the 77 plus the 82, because it's between those two numbers, and divide it by 2, which I get 79.5. Okay? So let me go ahead and box that up. There I go. All right. So now, step 3. Once I've done that, what I'm doing is I'm looking for the first quartile. So find the, well, essentially I'm finding the median of that bottom half, right? So find, I'll put in quotations, median of the bottom half. Let me rewrite that M here. The median of the bottom half. So I'm just looking at the bottom half. There's my bottom half right there, right? So I'm looking for the median of that. Actually, I can make that a little bit lower. So I'm looking for the median of that. So there it is, right? I can shorten that a little bit. Actually, you know what? Let's do it this way. Let's bring this down a little more. Oopsies. Okay, there we go. Bring this over. So that is a 71. And that would be considered my first quartile. Which is also known as a 25th percentile. All right. Step 4 would be find the median of the top half, right? So that means I'm taking this half I'm going to find the median there. So the one in the middle is right here. So 88 is my third quartile, which is also named as my 75th percentile. All right, so let me see if I can fit this in a little more gooder. There we go. Yeah, that would be good. All right, so there it is. So now I found my first quartile, my second quartile, my third quartile, all right there. Okay, so let's continue on, and let's say, so this is telling you exactly what to do right there, right? So I just went through step 1, 2, and 3. I guess they call this step 3 as well, so we'll call this step 3, part 2, right? All right, so now let's talk about the interquartile range. Interquartile range, IQR, okay? So that is this right here. So for this particular data, my third quartile, so again, my third quartile is also known as Q3. My first quartile is known as Q1, and my second quartile is known as Q2. So my Q3 is 88. My Q1 is 71. So here I would have, this would equal to my 88 minus my 71. And my IQR is equal to, what was that, 17? Okay. So, here we go. On we go. So, outliers and quartiles. So, outliers. So, determine the first and third quartile, right? So, that's what we got to do. Determine the first and third quartile, which we got. The first quartile was, what was it, 77? No. 71. Yep, 71. 71. The third quartile was 88. Right? Compute the interquartile range. So that was 88 minus 71. And that gave me 17. Then when we look at fences, the lower fence is Q1, which Q1 was the 77, minus the 1.5 times the 17, which is the IQR. And then we have the 88. Oh, shoot. I keep on writing 71. It's really 70. I'm sorry. I keep on writing 77, saying 71. And then the upper fence will be the 88, which is Q3 plus 1.5. So let's take a look at what those are equal to. 71 minus 1.5 times 17. And I have a 44.5 as my lower fence, and then I do 88 plus 1.5 times, oopsies, not 15, 1.5 times 17, and I get 113.5. Okay, so my lower fence is 44.5, my upper fence is 113.5. So when I look at the data, anything that is outside the fence will be considered an outlier, right? So anything that's outside of this lower and upper fence will be considered an outlier, all right? Well, I hope that answers most of your questions. If there's any other questions, please let me know. Talk to you later. See ya. Bye.